And I mean, you've raised an interesting question with regards to the whole issue of scale, and I think this is the real distinction between something like Biota Eve and the contemporary EvoGrid, is the idea that, I mean, Biota Eve is fundamentally bottom-up in terms of, a relatively small number of simulators, but certainly, a simulation base where it is maintained by individuals or a couple of people at most. And I think the other interesting thing that has come out of the kind of contemporary EvoGrid is this idea of, if it is more than an idea, then it would require a certain number of people and a certain amount of maintenance. And are there things that exist in the open source domain that solve some of this? Well, perhaps, but it would still require a lot of people. In terms of your view as an artificial life simulation author, can you lend some ideas to how, the problems associated with it being such a potentially large, time-consuming and expensive process, how do you think, Bruce could scale down the EvoGrid to make it something that was more doable in a kind of artificial life simulation author's context?
Well, not really sure I have an answer for that. And we're talking specifically about the networked artificial chemistry simulation. It would seem to me that so what we're talking about with the EvoGrid, as I understand it, is that I'm sorry, Tom. My ideas are kind of being formed as I talk to you. And
well, that was the whole intention of the visions. The EvoGrid, recording was actually to catch that ideas being formed in audio in some regard. So, you've got nothing to apologize for. But I think what interests me is this, there are obviously two very distinct things, and this is something I've been saying through recent Biota Lives as well. The EvoGrid has become something which is actually quite removed from contemporary artificial life. But that is not to say that there are lessons in contemporary artificial life that won't benefit the EvoGrid. And similarly, I think this idea of simulation space scanning, there are a wide variety of techniques, which I think is why the Artificial Life Journal actually publishes on artificial chemistry as well. There are a wide variety of techniques in artificial chemistry that could probably benefit artificial life simulators in the long run. So, to answer my question to you, my sense is that there is mutual learning that can be done, and just because there are two distinct things doesn't mean that there can't be learning from either side. Specifically, what interests me about the idea of the EvoGrid, which I talked about in the last Biota Live, is the kind of metic view of the EvoGrid, that it stokes a number of minds and ideally would get them contributing back into something like the biota community or the broader artificial life community. So perhaps through these visions discussions, there will be people that come in that have an interest where I could say, that sounds very much like Breve, or that sounds very much like, one of your simulations, Scott, or that sounds very much like what Gerald Jung is doing, or basically match the participants in the EvoGrid with contemporary artificial life simulations with the benefit to the kind of broader community as well. Because I don't see these things as being, I see them being conceptually quite different, but I don't see them being kind of methodologically mutually exclusive. So, that's my own view with regards to the question that I asked you, that I think there are things that could come through the EvoGrid that would actually benefit contemporary artificial life. And I think my own concern with regards to moving from this idea of summoning the EvoGrid, which is what Bruce is doing currently, kind of traveling the world, talking to, I think it's something like, he's done 20, maybe 22 presentations associated with the EvoGrid at a wide variety of conferences. Plus, also, he now has about 25 advisors, which means that this Visions recording series will go on for quite some time. But through all of this, eventually, in theory, this thing called the EvoGrid will need to actually become something. And what interests me through that as an artificial life simulator is the wide variety of things that, and this is the discussion that Gerald and Jeffrey and I had with regards to the levels of detail in simulation, that there are certain kinds of simulation scanning that would work reasonably But the levels of detail issue is something where an artificial life algorithm will optimize immediately for it, and possibly even because artificial life chemistry algorithms in some regard are almost subsets of artificial life algorithms. So there's potential for optimization that would eliminate novelty. So what interests me through this as well is that there is also a kind of broader philosophy that artificial life simulation authors can kind of get together and a priori come up with reasons that these simulations won't work from their own specific simulation experience. So, yeah, I mean, I think there's some potential. I'm very receptive to what you say about this being something which appears to be too academic to, merit broader or longer-term interest, particularly with regards to your own specific interests of emergence. But I think really, I mean, with what Bruce is doing in summoning the EvoGrid, he is very intellectually hungry for people like you to kind of continue the participation because, artificial life simulation authors have a very applied set of experiences that just comes through writing code, maintaining code, getting things to try and work together, obviously things like graphical user interfaces, user feedback, all this kind of applied stuff will be still highly applicable to what Bruce wants to do with the EvoGrid in the future. Does that make sense to you?
It does. I want to reel back to something that you said earlier, which was that you didn't see a divide between artificial chemistry and, artificial life. I think that there are many definitions of artificial life. I know there are. So that may be true in how you're using the terms. I do see this division in that with artificial chemistry, what you're talking about are, having a set of rules where, inanimate chemicals interact. So a physics and a chemistry. And with the idea that, anything that could arise from that would be sort of intrinsically part of the environment. And so if you were to observe a creature with a particular, genotype or phenotype emerging from that, it would really be, the distinction would almost be in your perception of it. That it would just, as far as the artificial chemistry simulation was concerned, it was just simply another chemical in the soup. So, so that the idea that, there might be something like a genome, that's an abstracted concept that really wouldn't exist in artificial chemistry simulation. So, that's roughly how I understand it. Does that make sense to you?
Okay, so using this example, let's put the artificial life simulation of plants as being something that is equidistant between what you're describing as artificial chemistry and what you're describing in terms of kind of intentionality in artificial life. And I think the artificial life simulation of plants in particular, there's some theory somewhere along here which just sees a kind of combination of causal processes. And what you put in terms of intentionality with regards to artificial life simulation exists also in the artificial life simulation of plants and artificial chemistry if you look purely at kind of logical causation. So, my sense is that by your definition, would you consider the artificial life plants as being more artificial chemistry than they were artificial life?
I'm not in. What are you referring to exactly? So, is this an existing simulation?
Well, there are a number of existing artificial life plant simulations. For example, we had, I want to say University of Paris, but they're based in Paris. They're, I think, the mathematical school from University of Paris. They were on probably a year ago now on Biota Live. Obviously, Bruce's original Nerve Garden is, like one of the, formative artificial life plant simulations. There are a wide variety of L-system derivatives that go in a variety of directions. There you have a system which basically, when you have an independent, like an intelligent agent or something like that existing in an artificial life simulation, there is obviously a degree of intentionality that is pre-programmed in that simulation. But where you have an artificial life plant simulation, you have metrics like minerals in the soil, sunlight, water, and sunlight and water can exist in kind of vectors as well. They're not just scalars that are kind of dumped down on the plants. But the plant's response to that is very much, simple kind of causal response, almost in some regard like a cellular automata in some regard, although there are obviously underlying genetic components. And the fellow's name is skip my memory, but the fellow who appeared on Biota Live talked about, them adding things like, predatory insects eating the plants and these kind of things.
Sure.
So what you described with regards to an agent and intentionality and how these things kind of move together on the agent level is almost a kind of anthropomorphic description associated with the causation that is applied in the simulation. Where you have an artificial life plant, in some regard, because it's bonded to something, it has very limited movement. I mean, aside from the leaves tracking the sun, these kind of things, it is a far more kind of causal thing in terms of, just getting nutrients, growth, what have you. And then you have, as you say, artificial life chemistry, where these things are completely, they're not anthropomorphized in any way. You just have a series of causal processes that, will put them together, and it follows a set of rules. I mean, my point is that the underlying causation is the same throughout, although all can embody some view of, kind of determinate or indeterminate chaos with regards to, underlying random noise or these kind of things. They're basically the same kind of causal simulation fundamentally. I mean, what do you see as the distinction?
First of all, Bruce did demo, I believe, that at least one of those plant simulations I'm recalling now, the Graython. And I do see a difference and so you're kind of contrasting something like that where it might have a list of plants and their location, number of leaves and their size and so on, and minerals and predatory insects, all as sort of abstracted concepts that the simulation knows about. Those are the simulation primitives. And you're contrasting that with the simulation, which I don't even know if such a thing exists, but let's say you had a simulation in which you had all those same entities, but the simulation was just very low level, just simulated the chemicals, and really had no idea that those chemicals were chained to form photosynthesizing plants and so on. Is that the distinction that we're drawing?
Why not?
Okay.
Follow on with the thought.
All right. Does the second exist that you know of?
Well, I certainly know of molecular simulations that where, in obviously the Dick Gordon example, where the molecular components to the simulation are then grouped and considered, bigger and bigger molecules, basically, to the point where they, become lipids and these kind of things. I mean, my sense is that on that level, the simulations exist, and certainly, if we're just, talking purely in a kind of theoretical space, I mean, one can imagine these kind of simulations working. I guess my point is more so there is this idea of simulation that all these things are shared with. And from this idea of simulation, artificial life simulations, you're saying, have a series of higher-level components which could be mapped with lower-level components, but we as simulation authors just choose to map them as higher-level components, which make them fundamentally different than the artificial chemistry simulation. This is what you're saying.
That's basically what I'm saying. That as far as I understand, with a pure artificial chemistry simulation, the primitives would be very low level, and anything that would hopefully emerge would be unknown to the simulation. One difference that I see there is, well, say you have two different artificial chemistry simulations, and within each simulation, different entities have arisen. How do they communicate? because any kind of attributes that you could recognize, of those entities, that would be entirely your perception. The simulation wouldn't know about them.
But I think even in the artificial life example, and I mean a wide variety of intelligent agent simulations, Swarm, take it back to kind of the first intelligent agent simulation within the context of artificial life at least, there are emergent properties which the simulation has no knowledge of that only the observer can see. I mean, I think this is what's particularly fascinating as a simulation author is you start to say, okay, well, when you get the intelligent agents where they start behaving like communities, do you start simulating a mean and a radical and start, creating some kind of social simulation at that context, or do you just keep doing what you're doing? And really the external observer is the only, I mean, you can write algorithms to find these things, but I don't think it's an intrinsic part of the simulation. I mean, what interests me is that this exists not just in artificial chemistry simulations, but also artificial life simulations, and it doesn't perturb or in any way diminish the results that come out of the simulations. I think the idea of the simulation knowing and optimizing, or it being intrinsically written within the simulation, is almost something that really, if we're going to, move into science of e-religion or any of these kind of things, ideally we'd want to be as far away from the explicit writing of the emergent properties as possible. So, I mean, I think all these things are interesting in kind of broader simulation philosophy, but I'm still, I guess, I mean, my view is that it's extreme. If the EvoGrid is successful, it will actually create an artificial life simulator. I mean, that's the aim, right?
Mm-hmm.
So the idea with regards to simulation coming to a self-realization that it's actually created, living things or things with life expectancy was really Dick Gordon's original test for this emergent EvoGrid. And I think, that the EvoGrid needs that specifically. It's an interesting idea because what we are doing in even discussing this is we're already identifying things from the EvoGrid that would kind of benefit the broader artificial life simulation community, and probably a wide variety of other, if intelligent agents are moving in their own particular direction as kind of intellectual movement, I mean, obviously that would benefit the kind of intelligent agent community as well. So, I mean, I think what we're doing here just by talking, we're kind of getting a sense of the possibilities that firstly, the simulation community can bring to the EvoGrid, but also the potential that could come from the EvoGrid. I mean, in terms of this thing, as you've described it, it's kind of academic extreme. Do you think there's a need for Bruce to find a means of translating these things as they're found to the kind of broader, in one case, biota community? I mean, do you see that as being necessary?
Well, I'm not sure it is. I mean, so I just want to be clear. When I said that this seems like an academic exercise, I wasn't putting down academic exercises. And there may be all kinds of applications. As you said, terraforming asteroids or developing other processes once we understand how to make things self-replicate. There could be all kinds of applications I'm just not thinking of. I guess the fact that it doesn't specifically speak to me, I think that's fine. Can you restate the question?
So the idea, and I mean, really, this is kind of wrapping up this visions discussion. But sure. The idea is that there are things that can come from the EvoGrid, and I'm not here. Your point with regards to academia is very valid. I mean, there are things that academics talk about endlessly that have no practical use to artificial life simulation authors at all. I mean, that's a valid point. I'm not trying to deny that point at all. But there are things that can come from the EvoGrid, which I want to really bring through this visions discussion, that could benefit the kind of broader biota community, could benefit you specifically, Scott. So in your ideal vision of the EvoGrid, Bruce gets millions of dollars of funding. He brings together brilliant programmers. They design and develop the EvoGrid, and it's been running for, say, 5 to 10 years.
Mm-hmm.
In this vision, what's some of the amazing stuff that you'd like to see come from the EvoGrid?
Well, as a developer, one interest I'd have is it being or providing some kind of platform where I could develop simulations more easily, and they could, run on many CPUs and, just sort of exploit the power of the platform. And I would like it to be as flexible as possible. So, for me, if I as a developer have to buy into all kinds of constraints that don't really fit my simulation, that would be an issue. So, for example, if the only way I could play in the EvoGrid was to have my simulation support a three-dimensional physics, I'm not saying that is a constraint on the table, but if it were, that would make it less appealing to me.
But if the EvoGrid provided that three-dimensional physics for you, that would be good.
Yeah, I mean, if I wanted to create a three-dimensional physics simulation, and the EvoGrid made that easier, then that would be a good thing. But one idea I have about artificial life development or simulations in general is that there's a real balance between the kind of complexity of the physics and the speed at which the simulation runs. And that if you're going to try to harness the power of natural selection and mutation and so on, what you really want is for the simulation to run as quickly as possible. So in my mind, there's sort of an optimal physics in which you can get kind of interesting, open-ended, emergent properties. And that may not be a three-dimensional kind of physics. It may not be a real-world physics at all. So basically, I want the option, at least. I want the option to kind of develop my own physics with its own constraints. And, if it can communicate with other simulations, for me that's a benefit, but it's sort of a less important aspect of it.
And in terms of the potential for this to exist in the future, I mean, I think what interests me with regards to all these kind of ideas, I mean, XML is a good example of this. If you talk to people 20 years ago about the kind of things that you can do with the contemporary internet, the bit that is missing is obviously XML in terms of the understanding of 20 years ago versus the contemporary internet. I think what interests me with regards to your description is that it is not just about presenting you with these kind of options. There may actually have to be some new kind of technology or some new kind of insight that will actually enable these things to be possible. I mean, does that also resonate with you?
Something like XML, or? Well,
no, XML is a relatively neutral example.
Sure,
what I'm saying is, in these ideas of simulation science, for example, as a kind of broader emerging intellectual phenomena, there are components, particularly with regards to atomization, as you say, with regards to distribution of simulation, which will require different kinds of simulation methodology in the future in order to actually create these kind of... So it's not just a situation where Bruce would come to you and say, with your existing knowledge now, you can develop any kind of simulation. There may actually need to be some learning and some new ideas, basically, that will actually facilitate this. I mean, does this make sense to you?
It does. And, and regardless, I mean, there may be certain types of simulations that will be outside of, outside the boundaries of the EvoGrid. And so that's kind of where I'm at. I'm very interested in the possibilities, and I accept that, the simulations that I may want to write might not fit in neatly into the EvoGrid. So, and to me that's okay. It's not ideal, because I do see the ideas as being very powerful, But, one concern I have, for example, is about this issue of time. That at one point there was a discussion of how to ensure that that simulations that were interconnected had the same sense of the passage of time. And to me, that seemed like maybe not a limitation I wanted to impose upon my simulation, because I might have one where I really want to run as fast as possible, and for me, that might mean that when there are fewer creatures, it runs much faster than when there are a lot of creatures, and I don't necessarily want to sacrifice CPU in order to have a regular heartbeat. So it's kind of my thinking on that.
So in terms of your simulations that you're working on currently in the near future, Scott, what people got to look forward to in that regard?
To be honest, I haven't really been devoting much time to it lately. I've been working for 3 different companies on 5 different projects, so the hobbies have taken a back seat. But the most current project I have up it's my attempt at a framework. Was more or less a proof of concept, and in reaction to some of the ideas I heard about the EvoGrid, and that's on ripplingloop.com. The framework is called VatLife. Basically, as I said, it was kind of inspired by the EvoGrid. It's a relatively high level simulation in that it's not your artificial chemistry simulation for sure. But what it does essentially is it abstracts the idea of environments and the organisms within them and the control logic that governs each artificial life form. So, for example, the cognitive simulation that you developed for Noble Ape, my idea was, I'm developing these simulations in which I'm creating the physics, I'm creating the creatures, and I'm creating some way of interpreting the genomes of the creatures and giving them some logic based upon that. And my thought was, wouldn't it be nice if I could just take, say, the Noble Ape cognitive simulation and just, have it work within my program without having to either modify it or modify the simulation itself. So that was one of the goals there.
Pretty cool.
Yeah.
You were working with Gerald de Jong for a period of time last year associated with kind of RNA or artificial life like RNA. Can you talk a little bit about that project?
It was more of an email discussion. We were talking about the Nuance engine, and he was kind of helping me with some of the ideas that I had about VatLife. And I'm not sure we ever really arrived at a consensus, but it was a very interesting and helpful conversation. But the basic. Can I just talk a little bit about the basic concept of VatLife?
Certainly.
Yeah. So in the real world, we know that, we're all atoms and molecules, and our genomes, our physical forms are all emergent properties of our physics and chemistry. But in VatLife, I thought about the sort of the morphology as separate from the control logic of each creature. So it sort of it does blur the line a little bit between artificial life and artificial intelligence. But my thought was that each creature could be sort of abstracted to have a morphology and kind of a brain, which would be separate from the body. And so basically in VatLife you have environments which they basically express the physics and the fitness function and interpreting the morphology of each creature. So you might have a creature that has a genotype, which the one example that's up there, the artificial life forms are essentially polygons, and that's what they are. They're just very simple two-dimensional polygons, and the environment interprets that genome by producing a polygon for each creature. It's a very simple environment. The idea with vat life, again, is you could develop your own environments, and they can be mixed and matched and so on. But then the idea is that each creature also has a separate genome, which a controller. So, for example, I'm hoping one day your Noble Ape cognitive simulation could plug into this. But that controller, which is dynamically loaded, it's not part of the vat life framework. It exists as separate jar files. So that could be loaded and be handed a genome and produce a mind from that. And then that controller can communicate within the environment. It can essentially operate the logic of each creature. And the idea is that that's completely generic, so any controller would work in any environment. And and eventually there would be an idea that the same kind of creature could migrate between environments that might be somewhat different. So that was kind of a lengthy explanation there. I hope it made some sense.
Certainly. And you've mentioned your blog for people wanting to kind of get the ongoing development associated with this project, and obviously I'll put a link through to your site and contact details associated with this podcast. Scott, is there any final thoughts you want to leave the listeners with regards to your own particular vision of the EvoGrid?
I think it's a very interesting project, and I hope it succeeds in whatever form that takes. Just as far as artificial life in general goes, I think it's a pretty exciting time that we have all this computing power available to us, and my hope is that we're really going to see the application of artificial life techniques, and particularly that harnessing evolution for our own purposes, that it's going to really have transformative possibilities. So, and I do think biota is a part of that, and the EvoGrid.
Well, I'd like to thank you, Scott, for participating in this first Visions of the EvoGrid recording. I know it's probably quite challenging with absolutely no previous audio or sense of direction, but I think we've wandered through a number of points and certainly pointed out a lot of the stickiness associated with the EvoGrid and related projects and ideas. So, thank you very much for the chance to participate in this first Visions of the EvoGrid.
Great. Well, thanks for giving me the opportunity, Tom.